And here we go again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on to section 14.1 and then eventually 14.2. But before we do that, are there any questions from last night's homework, section 3.7 or 4?
That should work, right?
What's that?
Any questions?
You have a question? Okay, what is it? Is it a specific question from WebAssign you want to look at? Hello?
Hello? Are you talking to me?
I'm talking to whoever said I have a question.
I didn't.
I thought somebody did. Well, okay. We'll go on then. Yeah, here we go. Okay, so we're going to take a look at section 14.1. All right. As many of you know, this class is a prerequisite for statistics, Math and 146. It's also a prerequisite for other classes as well. But in statistics, there is notation that is often used in some of the formulas. And that notation is called factorial. And what it looks like, here's an example. Let's say we have 4 followed by an exclamation mark. That means 4 factorial. So that exclamation mark after the number implies that we're going to use factorial in this situation. What does that mean? Well, 4 factorial is equal to 4 times 3 times 2 times 1, which is equal to 12 times 2 times 1, 24 times 1, 24. So 4 factorial is equal to 4 times 3 times 2 times 1, or 24. Any questions about this specific example? All right, let's take a look at another example. Let's say we have 6 factorial. Well, that's equal to 6 times 5 times 4 times 3 times 2 times 1. 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. 720 times 1 is 720. So 6 factorial equals 720. So 10 factorial would be equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you kind of got the idea of what factorial, what the notation means. Any questions on that? All right, consider this. Let's go back to 6 factorial. If 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1, wouldn't that be equal to 6 times 5 factorial? Because wouldn't that be 5 factorial? Okay, so I could take 6 factorial and write it as 6 times 5 factorial. Or I could write it as 6 times 5 times 4 factorial, because 4 factorial would be equal to 4 times 3 times 2 times 1. Getting that idea? Let's find out if you are. Okay, let's see here, and we'll get to this eventually. Let's see. First of all, let's take a look at this. We've got 3 factorial times 4 factorial. So 3 factorial would be 3 times 2 times 1. And 4 factorial would be 4 times 3 times 2 times 1. Okay, well, let's see. 3 times 2 is 6, times 1 is 6, times 4 is 24, times 3 is what? 72, times 2 is 144, times 1 is 144. Okay, so this is equal to 144. All right. Basically 3 times 2 times 1 times 4 times 3 times 2 times 1. Okay, now, what if you had this situation? I'm waiting for you to finish writing there, and that's just fine. You good to go? Yeah? Okay. What if you had 49 factorial over 47 factorial? This seems like it would be a horrible problem to write 49 times 48 times 47 times 46, on and on and on, all over 47 times 46 times 45. But consider this. 49 factorial would be 49 times 48 times 47 factorial, right? And in the denominator, I've got 47 factorial. Well, 47 factorial over 47 factorial is going to reduce down. So now all I've got to do is take 49 times 48, which is 2,352. So all I really had to multiply was those two numbers, or were those two numbers. Are you okay with this? Any questions there? All right, how about this example? 101 factorial over 100 factorial. Well, we could take the numerator and write it as 101 times 100 factorial, and the denominator is 100 factorial. Those reduce down, and we just have 101. How nice is that? Again, any questions about this? Okay. How about this situation where we've got 9 factorial over 11 factorial? Well, the numerator could be written as 9 factorial. The denominator could be written as 11 times 10 times 9 factorial. Now, let's go back here. Notice that I didn't cancel the 47 factorial over the 47 factorial. I simplified it, reduced it down to 1 over 1. Same thing here. That reduces down to 1 over 1. It doesn't cancel. So here, these do not cancel. They reduce down to 1 over 1. So what we've got now is 1 over 110, because 11 times 10 would be 110 times 1 would still be 110. So our final answer, 1 divided by 110. And don't punch that into a calculator and get some awful decimal number that then you round off and then it becomes wrong because you rounded off. Just leave it as a fraction, okay? Any questions there? All right, now, by definition, 0 factorial equals the number 1, okay? So don't try and figure out, well, but what about this, what about that? Just, that's a definition. 0 factorial equals 1. Trust me, it works, okay? All right, let's say we've got this scenario. We've got 9 factorial over 7 factorial times 0 factorial. Well, in the denominator, 7 factorial times 0 factorial would be 7 factorial times 1, which would just be 7 factorial, right? The numerator, I could take 9 factorial and write it as 9 times 8 times 7 factorial. Why do that? Because now I can reduce out the 7 factorial over 7 factorial. 9 times 8 is 72. Any questions there? Okay, let's take a look at this situation. 5 factorial divided by 1 factorial times the quantity 5 minus 1 factorial. Well, let's see. In the numerator, 5 factorial. We'll just leave it as 5 factorial for right now. What is 1 factorial? That's just 1. Okay. And then 5 minus 1 would be 4 factorial. Well, and 1 times 4 factorial is just 4 factorial. So now I'm going to rewrite the numerator as 5 times 4 factorial so that it will reduce out the 4 factorial in the denominator, and I end up with just 5. Any questions there? Okay, let's take a look at, let's see here, this one. 6 factorial over 4 factorial times 6 minus 4 factorial. That's 6 factorial over 4 factorial times, let's see, 6 minus 4 is 2 factorial, all right? Well, I can take the 6 factorial and use it to knock out the biggest factorial in the denominator, the 4 factorial. So I'm going to write 6 times 5 times 4 factorial. In the denominator, I'm going to take 4 factorial as it is, and then I'm going to write 2 factorial as 2 times 1. Okay, any questions so far with this problem? Again, do you see how I'm pulling things apart so that I can reduce them out? So now the 4 factorial in the numerator and the denominator reduces down to 1 over 1. I can reduce this thing further. The 6 over the 2 reduces to 3 over 1. So now in the numerator, I've got what? 3 times 5 in the denominator. Actually, 3 times 5 times 1 in the denominator, 1 times 1 times 1, which is 15. And I don't need to rewrite this. I could go straight there to 15. It's just a matter of how much you want to simplify at a time, or how many things you want to simplify at a time. All right, we doing okay, everybody? Any questions? Okay, let's take a look at this one. 5 factorial times the quantity 8 minus 5 factorial all over 4 factorial times 7 factorial. Well, the first thing I'm going to do is take the quantity in parentheses, 8 minus 5, and rewrite that as 3 factorial. Okay. Now, there is a variety of ways that I can reduce this thing down. Okay. I could take these two and reduce them, or those two and reduce them, or those two and reduce them, or those two and reduce them. You know, it's just a matter of how you want to go about it. It isn't necessarily that one thing is right and the other thing is wrong. Okay, let's see here if I can get this to work right. There we go. Probably would have been faster just to recopy this thing, but I'm just obsessed with trying to figure out if I can do this. You know what? Let's just go back and rewrite it. So we're going to go back to this. Before I mapped out all the possibilities. Let's see. What I'm going to do is I'm going to deal with this. So that's going to be 5 factorial on top and 7 times 6 times 5 factorial on the bottom. Okay. And then I'm going to deal with this, which is going to be 4 times 3 factorial on the bottom and 3 factorial on top. Now, why did I do that? Because I looked at it and I thought, how can I take out the most amount of stuff all at once? And if I hadn't done it this way, I could still get it reduced down eventually one way or another. But this way, the 5 factorials reduce out and the 3 factorials reduce out. And in the numerator, I have a 1. In the denominator, I have, let's see, what do I have? I have 4 times 7 times 6 times 1, which is 168. And again, I'm going to leave my answer as an exact fraction, not a decimal. Okay. Any questions about this problem? All right. Let's take a look at this one. 6 factorial times 7 factorial over 8 minus 3 factorial times 7 minus 4 factorial.
My internet don't want to work.
What's that?
So my internet barely started working, but I wanted to ask, what does factorial mean? Like when you say that?
Okay, let's go back up here. So factorial, if you have a number followed by an exclamation mark, then it's that number times the integer 1 less than that, times the integer 1 less than that, times the integer 1 less than that, all the way down to 1. So 4 factorial is 4 times 3 times 2 times 1. Okay. 6.
Okay.
You got it?
Yeah, I got it. So if it will be 5, it'll be 5, 4, 3, 2, 1.
Yeah, 5 factorial, yes. Okay, now, the first thing I'm going to do, however, is I'm going to take 8 minus 3, which is 5 factorial, times 7 minus 4, which is 3 factorial. All right? And again, I'm going to use factorials on top and bottom to reduce them down. And both of the ones on the top can consume the ones on the bottom, so I'm not going to worry about which order I do things in. I'm going to take 6 factorial on top and write it as 6 times 5 factorial so that I can knock out the 5 factorial on the bottom eventually. Then I'm going to take 7 factorial and write it as 7 times 6 times 5 times 4 times 3 factorial. And I'm going to use that to knock out the 3 factorial on the bottom. Okay? So what do? I get rid of the 5 factorial and I get rid of the 3 factorial. So now on top, I've got 6 times 7 times 6 times 5 times 4, and then of course times 1, but I get 5,040 all over 1, so just 5,040. So all I have to do with my calculator is I'm taking this times this. Okay. Questions on that one? All right. What if things get really horrendous? What if we have something like 11 factorial? Well, I could sit here and go 11 times 10 times 9 times 8 times 7 times 6 times 5, etc., etc. But there's got to be a better way, and there is. Okay. So now we're going to talk about a calculator. I'm going to start with the calculator that's recommended for this class, which is the TI-30X Roman numeral S or Roman numeral B. The S stands for solar and the B stands for battery. Okay, this is just one of many calculators. On this particular calculator, looking at the screen, let's see here. There's a button right about here that says PRB. And when you push that button, this shows up. It goes in PR, and then it has in CR, and then it has an exclamation mark. Okay, now this is just one calculator. Yours might be located somewhere else. And in a minute, I'm going to show you where there's a calculator online you can use, so don't panic. But I have this factorial button. So what I could do on my calculator is I could type in the number 11 and then push the PRB button and move the cursor over to where it's underneath the exclamation mark, and then push equals. Now I have 11 factorial. I'll push equals again, and I get 399,16800. So 39,916,800. Okay. Now, what I'm going to do next is I'm going to go to the internet and take a look at a calculator. So give me just a second here. I'm going to type in scientific calculator. So let me change my sharing. Can you see where I've got, see the dragon up there, and I've got scientific calculator?
Yes.
All right.
Yes.
So then I'll push enter, and hopefully it brings this up on the screen for you. Okay. Right there is the factorial button for this particular on-screen calculator. All right. Now, the problem I just did was 11 factorial. So let's go in and type 11 factorial. Can you see that? And then equals, and there's my answer, 39,916,800. So again, if you have a handheld calculator that you can use, that's great. If you don't, type in scientific calculator, and hopefully it'll bring this calculator up. All right, let's take a look at another problem. Let's see here. I'm going to clear this out. Let's do 55 factorial. And then equals. Now, what is all this strange notation? 1.2696403, and then it has a little e and a plus 73. Okay, so I'm going to copy that on my whiteboard screen, and then we'll come back and talk about it. 96403 e plus 73. Okay, so I'm going to go back to. All right, so now can you see my whiteboard screen?
Yes.
Thank you. This notation right there basically means that we have 1.2696403 times 10 to the 73rd power. So this little e in this context, only in this context, means 10 raised to the 73rd power. So that's what that e notation is. Okay. There's a number e that's 2.7, etc. And we'll talk about that later in the quarter. But for right now, it's just meaning 10 to the 73rd power. All right. Any questions about that? Okay. So what I want to do right now is I'm going to stop the recording. I know it isn't really halfway through the class, but this section is shorter than the other one. So I'm going to stop the recording. We'll take a 5-minute break. We'll come back and we'll go on to section 14.2. Okay, so I'm going to stop the